Okay, guys, we did most of 9.3 last video. We talked about parametric slopes and concavities and arc length. And in the spirit of taking our time and making sure you understand, we're going to do a whole nother day on this, and we're going to do a example where it gives us a set of parametric equations and asks for vertical and horizontal tangents. So this is another Calc 1 skill. You find a horizontal tangent line, basically you're finding where the slope is 0. And a vertical tangent line is when the slope is undefined or number over 0. So let's just review. The slope of this graph in terms of x and y is going to be dy d theta over dx d theta. And we used t last time to talk about the derivative, but theta is our parameter now because we're dealing with sines and cosines. And a lot of times, for whatever reason, when we deal with trig, we do theta. Just like we used to use x, and when it got to trig, we'd use theta. Same with parametrics. When we graph this in our calculator, you're still going to use t in the same way that if you were graphing y equals cosine theta in your calculator, you would have to type in cosine x. So don't let that confuse you. We're just using theta instead of t. Actually, let's go ahead and check the graph out so we can kind of get an idea of what we're looking for. We're looking for vertical and horizontal tangents of this graph. So with my calculator in parametric mode, I enter my two equations and go to graph. And you get this cool little bow tie sort of shape. I love parametrics because they generate graphs that you've never dealt with before and you've never seen, but equations still generate them. So they come from plugging in different values of theta into the x and the y. So it looks like we're looking for 4 answers for our horizontal tangents. There's going to be a horizontal tangent up here, and up here, and here, and here. And it looks like vertical tangents here and here. So we're looking for 6 answers overall, 4 horizontals, and 2 verticals. So that just gives you an idea. You're supposed to, according to the directions, confirm with your graphing utility. So we'll just go ahead and confirm first that there are 4 and 2, and then we'll find them, and hopefully they'll match up. Okay, so basically, if this is the derivative, dy dx, one of two things is what we're looking for. We're looking for this to equal 0 or to be undefined. Our horizontals are going to be when the top is 0, because if a fraction is going to equal 0, the top has to equal 0. So we're looking for where is dy d theta equal to 0. You don't even really have to find the derivative. You can just do it in 2 parts. So we need to take the derivative of y with respect to theta, set it equal to 0, and solve. So let's start by finding the derivative. The derivative of 2 sine 2 theta. So let's see. We have a 2 that's just along for the ride. The derivative of sine is cosine. So I get 2 cosine 2 theta. But then the chain rule says I need an extra 2. So this is my u. So this would be my du. So overall, I get 4 cosine 2 theta. And remember, in order to be horizontal, I need for this thing to equal 0. So where is 4 cosine 2 theta equals 0? Divide by 4, and cosine 2 theta has to equal 0. So where is cosine 0? And by the way, this graph got completely drawn once in 0 to 2 pi. That can adjust sometimes, and the graphics don't look like, it makes it look like it didn't quite finish, but that's just lousy graphics. So 0 to 2 pi is one complete revolution of this graph. So I'm looking for theta values between 0 and 2 pi. Otherwise, I'm just recreating horizontal tangents that I already had. So now your next question, back to your good old trig equation days, is where is cosine 0? Because 2 theta needs to equal that. Okay, so cosine is 0. From 0 to 2 pi, cosine in my x is 0 up here at pi over 2, and down here at 3 pi over 2. So 2 theta can equal pi over 2 or 3 pi over 2. Just to make sure I don't miss any, because sometimes when you have your theta multiplied, you can miss answers. So I'm going to express this instead as pi over 2 plus pi n, just to be safe, because pi over 2, 2 pi over 2, excuse me, pi over 2, 3 pi over 2 5 pi over 2, 7 pi over 2, and so on. Now if I divide by 2, divide everything by 2, I get pi over 4 plus pi over 2n. So now's when I check that I only use between 0 and 2 pi. So I need to use these values, as many of them that I can, between 0 and 2 pi. So my actual angles, because of that 2 there, these aren't my angles. My angles are pi over 4 plus pi over 2n, which is plus a quarter of the way around the circle. So pi over 4 plus pi over 2 would be 3 pi over 4. And then another pi over 2 would be 5 pi over 4 and 7 pi over 4. Okay, so those are the 4 values that when plugged in for theta give me, plugged in right here for theta, give me an answer of 0. It's probably been a while since you solved a trig equation. It has been for me too, so those 4 answers caught me off guard. I was just expecting the 2, but that 2 times the theta is what made us divide by 2 and get the 4 answers. So anyway, these are the theta values that give me a horizontal tangent line. Now, unfortunately, the answer is not those 4 numbers. The answer is the xy points that come from those 4 theta points. So you could plug in pi over 4 into x and into y. Let me recopy my equations. If x is cosine theta and y is 2 sine 2 theta, then plug in pi over 4, and your result is going to be cosine pi over 4 for x and 2 times the sine of pi over 2 for y, because I doubled pi over 4. In other words, let's see, cosine of pi over 4 is square root of 2 over 2. And 2 sine pi over 2. Sine of pi over 2 is 1. Double that and you get 2. So square root of 2 over 2, comma 2. That's our first point. And that is right here. Square root of 2 over 2 is 0.7-ish. And so I'll go over 0.7-ish, up 1. You can tell from the symmetry in this graph that all of my points are going to have these same values. It's just they're going to be some positive and some negative. And if we look at our table, let's see if I can input t's. Let's try it. If I input the t square root of 2 divided by 2, it kind of worked. It rounded a little too much. So forget that. We'll just plug them in unofficially. But like I said, you can tell from the symmetry of the graph that that's going to be one answer. The one that's reflected over the y-axis would be this one. Then you've got negative square root of 2 over 2 and then down 2. And then you've got positive square root of 2 over 2 and down 2. And that's the 4 points that were shown in my picture. Forget that table, it didn't work. But those are the 4. So anyway, that's my horizontal. My tangents, my vertical tangents are going to be the ones where the bottom of that original fraction is 0. If you want this slope to be undefined, which is in a graph of vertical tangent, then you need dx d theta to be 0. So let's take the derivative of cosine and set it equal to 0. Derivative of cosine with respect to theta is negative sine theta. And where is that 0? Because this is the bottom of the fraction, and that being 0 gives us vertical tangents. So let's see, negative sine 0 is the same place as where sine is 0. So my unit circle, sine is 0 when y is 0, at 0, and at pi. No weird answers because this is just the sine. So theta equals 0 or pi. And then you just plug 0 and pi back into your original 2 equations. I'll kind of cut to the chase to make sure this doesn't go too long. Plug in 0 and pi, and your 2 points are 1, 0, and negative 1, 0. And again, look at your graph 1, 0 here, negative 1, 0 here. Those are the two locations where we have vertical tangents. Okay, so we'll call that 9, 3, day 2. Just a little bit more practice. We're in no hurry, so there you go. Parametrics, Young out.